We're going to spend most of the rest of this session talking about network topology. There's a little bit of, it's going to get a little bit confusing. I'll tell you that right now, but I'm going to try and clear up that confusion for you right now. And as we go through it, because there's two types of network topologies we're going to talk about. We're going to talk about physical topology and logical topology. And they're two different things. But some of the confusion in when we try and talk about them is that they use the same terms, but they mean different things. So it's going to get a little bit confusing, but I'll have some examples for you at the end, which will hopefully make it clear what the difference between a physical topology and a logical topology is. Okay. So when we talk about the network topology, we're essentially talking about how nodes are arranged, and the connections within that network. Even if you have organizations that are identical or they're the same size, their networks are going to be different. The way they lay out their networks is going to be different. Again, because of all the security and performance requirements, and we'll talk about fault tolerance. Every company will have a different tolerance for a certain amount of failure. And so depending on what, when you think about cost, when you think about security, when you think about performance, when you think about fault tolerance, really those four things that will govern what type of network topology you put in place. Okay, so you can think about topology as the way that the nodes and the connections are arranged. Okay, one is physical, one is logical, one is more related to communication, but it certainly impacts the way your network is going to perform. Okay? So the physical topology, it talks about how devices are physically connected. Okay, so you can think about essentially the shape of the cabling layout used to link the devices as the physical topology. So that that would refer to the layout of the cabling, the locations of the nodes, the interconnections between the nodes, and the cabling. Okay, and the physical topology is going to be determined by at least three factors, which I mentioned earlier. One, the capabilities of the network devices and media. So we talked about the different types of connections, whether it's fiber, fiber optic, copper, wireless, the amount of fault tolerance that's required, right? And we're going to go through each of these different topologies, and you'll see what the advantages and disadvantages are. But each of these pictures that you see here on the screen represent different types of topologies. But then the third is the cost. So just as an example, you can see here, without me even explaining to you what a mesh topology is, you can see here there's a lot more cabling required than here, right? So obviously more cabling, more cost. Now, are you using fiber optic? Imagine if you're using fiber optic and you need this much more cable compared to this, what the cost of that might be. If you're looking at something like this bus topology, what would happen if this main segment had a break in it, right? The entire network, and again, I haven't got to explaining it to you, but just by looking at the pictures, your desired fault tolerance, if it's high, this might not be the best choice because one break in this segment and your entire network breaks down. Okay, so there's lots of reasons to choose a particular topology, and these are some of them. Okay, so the logical topology, unlike the physical topology, describes how data should transfer within the network, not how the network is laid out. Now, like I said, the only confusion here is some of the topologies that are physical and logical use the same terms, but they mean different things. But let's try and get around that. Okay, so the two most common logical topologies are the bus and ring topologies. Okay, so what I showed you before, you can see even with the physical topology, there's a bus topology and a ring topology, but and we're going to talk about those shortly. but I just want to finish off with the logical topology, and then we'll come back to the physical ones. So the two most common logical topologies are the bus and the ring topology. Okay, the logical bus topology is used by most modern networks. Okay, in this topology, again, remember, logical means how the data should transfer within the network. Okay, don't think about the physical connection. But under the bus topology, all the nodes on a network transmit data to all the other nodes. Okay, and then it's up to each particular node to decide whether or not that data or that information or that packet was intended for the node in question. Okay, so the logical bus topology is just about how data is transmitted. It means it's transmitted to all of the other nodes, and then the nodes have to decide on whether or not it belongs to them. Okay, you compare this to the physical bus topology, right, which was up here, and again, we'll talk about that. Sorry, it's a little bit cyclical, but that's how it is. The physical bus topology, which is shown in this picture, that refers more to how the equipment, how the nodes and the cables are laid out. You can see in this case that there's a common bus, right? This segment here is called a bus, and each of the nodes is connected to this bus. But this doesn't tell you how the data should be transferred or how the data goes out. It's just saying physically that's how it's connected. But the logical bus topology says that the nodes transfer or transmit data to all the different other nodes, and then it's up to those other nodes to decide what belongs to them or what was meant for them. Okay. Now we have something. So two common logical topologies, like I said, are the bus and the ring. So bus, every node sends messages to every other node, and it's up to the other nodes to decide what was meant for them. Then you have the ring topology, which is different. It's sometimes called a token ring, and it's similar to that half duplex mode, but each there can only be one node that communicates at any given time on the ring, okay, or with that can send information out. And the only time you can send information is like it's a token. Once a device can request a token, once it gets the token, it has the right to send a message. And if another machine needs to respond, it has to request that token, and only when it has that token can it respond. Okay, so again, even though it's called a ring, it's not about the physical setup or layout. It's about the logical layout or the logical setup and the way that data is transmitted. So a logical bus topology means one node sends data to every node. A logical ring topology means only one node can talk at a time. Okay, you can have a mix and match of physical and logical topology. So I don't have to have a physical bus topology and a physical and then a logical bus topology. I can mix and match. Okay. Okay. Physical topologies are a little easier to wrap your head around because you can literally visualize them, and it makes more sense to me anyway. And so the topologies we're going to talk about are bus, the ring topology, a tree topology. We'll look at a star topology, mesh, and then a hybrid, which is going to be some combination of all of those. All right, so when we go through all of these physical topologies, I want to talk about one, how it's laid out, two, what some of the advantages are, three, what some of the disadvantages are. Okay, and remember, when we talk about advantages and disadvantages, they're going to boil down to some of the attributes we've talked about so far, which are cost, fault tolerance, or reliability. You can look at it both as one. So cost, fault tolerance, performance. So those would be three of the criteria that you would consider or that you would look at in terms of advantages and disadvantages. So in a bus topology network, every node is going to be connected to a central backbone or a central bus, right? That's where the word bus comes from, in some sort of a linear path. Okay, and you're going to find this primarily in cable broadband distribution, right? So think about if this were yeah, actually, if you look at it from a cable, from a broadband distribution, right? The broadband or the internet is going to be routed from here all the way here, right? So from the West Coast all the way to the East Coast. And all along the way, it's going to then branch out to connect to other networks. Okay, and that kind of topology makes sense for that kind of an application, right? So the advantages here are, one, it keeps the layout simple, and it's cost effective, right? You're going to have only, you just need to run that one single cable all the way from east to west or from one end to the other, and then everything just kind of feeds off of that, okay? But what are the disadvantages, right? So the main disadvantages here is that there's a single point of failure. So if anything happens to that backbone, right, all of the networks that are feeding, or all of the devices, or all of the nodes that are feeding off of that backbone would then fail. And on top of that, because all of the traffic is being sent via this backbone, as each of these networks or these devices start to send more and more traffic, what happens to the performance of the backbone? It starts to diminish, right? And so you start to have poor performance as these start to increase or start to use more network bandwidth. And the associated or the related issue is that it's not scalable. So in other words, not only can these devices not start to send crazy amounts of traffic on the network, I can't just add an arbitrary number of devices or nodes onto this backbone, because each of them will then start to contribute to increased amount of network traffic, and eventually the performance will bog down. Okay, so the bus topology is simple to understand, simple to lay out. It's cost effective, but there's a major problem in that there's a single point of failure in that backbone, and it's not scalable. You'll start to get diminishing performance. Okay, so that's the bus topology. Let's look at the star topology. Actually, I want to go back to that one. Right, so think about the question I was asking you before. What would your home office or home network look like? Would your home network have a common cable running through the entire house, and then each device would be connected off that common cable, that common backbone? Don't answer me yet. We're going to get to that answer at the end. But is this something that looks similar to what you might have in your home, right? Is there one cable that runs all the way through and everything connects to it? Okay. All right, let's go to the star topology. So in the star topology, you're going to have every node in your network connected to a central switch. Okay. And the relationship between the elements is that the central device, okay, so in this case, that switch in the middle is a server, and the other devices are treated as clients. And the central node then has a responsibility of managing data transmissions across the network, and in some cases acting as a repeater. Okay, so the brains of the network, if you will, are going to be that central switch. Okay, so with star topologies, these are most common, and they're most common because you can manage them all from one location. In other words, that central switch. So if a node that isn't the central node goes down, so if one of these nodes goes down, it doesn't impact your network at all. But if obviously if this thing fails, if the central switch fails, you don't have some sort of redundancy there, then you're going to have issues, right? So that's one of the advantages there, that any of these devices going offline, and we'll see with a ring network, it's different because a ring network is not managed like that. But in this case, we're not dependent on any of these devices. Okay, you can see here, even compared to the bus topology, there's a lot less required in terms of cable, right? There's not that single long cable that I need that runs from east to west or from north to south or from one end to the other. I'm just connecting these shorter pieces of cable from each node into that central device. Okay, so it should be obvious then, if those are the advantages, what the disadvantages are. Well, clearly, if something happens to that central switch, it's game over, right? And for those of you who have had router failures at home, or anywhere else for that matter, will know that, yeah, that's an issue. And then the performance is all dependent upon that router, right? It depends how that router is configured. Is it designed to handle high speed? Is it configured to handle high speed? And if it's not, then you're going to have performance issues. So again, relatively easy to manage, less cabling, but you've got, again, a single point of failure, and your performance is very, very much dependent on that central switch. Okay, then we've got the ring topology, right? So in the a ring topology, the computers are connected to each other in a circular format. So every device in the network will have two neighbors, not more and not less, exactly two neighbors. Ring topologies were commonly used in the past, but it's you'll be hard pressed to be able to find a company that uses these today. Okay, so the first node is connected to the last node to link the loop together, right? It's like like a ring. And as a consequence of being laid out in this format, packets need to travel through all of the nodes in order to make their way to their destinations. Traffic is only moving in, if you're going from one node from the first node to the last node, you have to go through every single node, okay? And within this topology, one of the nodes is used or is chosen to configure the network and monitor the other devices, okay? So the advantages are that the risk of packet collisions is very small. So we saw, above in these two, well, especially this one, you've got the risk of packet collisions between those different types from the different devices. Whereas here, everything's moving in one direction in a circular format. And so the risk of packet collision is a lot less, which is going to improve your performance, right? And you might argue that it's relatively easy to install because you're just connecting from one device to another, right, in a circular format. Now, one other variation of this is this dual ring format. Because with the single ring, traffic moves in one direction and it's highly prone to failure, single point of failure on that one ring. But if you have two directions, two rings, then you have less of a chance of failure and your performance goes up because you can send out traffic in one direction or the other. Okay. In fact, that was one of the reasons that people don't use ring topologies anymore, because once like I said, there's one node here, one of these nodes, whether you look at this one or this one, that's responsible for managing the network, monitoring the other devices and so on. And once that device, if that device were to fail, then the entire network would fail. Okay. And then obviously, as there's an issue here with scale, because as I start to increase the number of devices, the amount of the number of devices that my packet has to go through in order to get to my destination starts to increase. And so there's an issue with scale as well. Okay. All right. So that's the ring topology. Okay, then the mesh topology. So mesh topology is a point-to-point, is based on point-to-point connectivity where each of the nodes are interconnected. All right. In this topology, data is transmitted using two methods, either routing or flooding. Routing or flooding, and maybe you can imagine what that might mean. So routing is where the nodes use some sort of a routing logic to work out the shortest distance to the packet's destination. So there's some intelligence built in, and they figure out, what's the shortest path to my destination. Whereas if it were flooding, then there's no routing logic. You're just sending information to all of the nodes. Okay. So the advantages here are it's very reliable. You can see, for me to trace a path, from this machine to, let's say, this machine. I mean, look at the number of paths I have. Right? It's a lot of them. And so if there's an issue with any one of these cables or connections or any of these segments, then essentially I can use a different route. And so it's highly reliable. And so there's essentially no single point of failures. But what's obvious to you here with setting this thing up? If you had to set this up at your house or at your office, what's obviously complex to do here? Right, that whole cabling, it means you have to essentially run a cable from every device to every other device. And now what happens when you put one more device on the network? You have to run that many more cables. So again, depending on your use case and depending on what kind of cables you're using, that could be, first of all, very expensive, and second of all, very time consuming. And then, trying to get that all configured is going to be an added level of complexity. The tree topology, which maybe from just the name and the picture, you can guess what it is. But as you can see, as the name suggests, a tree topology is a network structure that's shaped like a tree with many branches. Tree topologies have a root node. So in this case, it's this node over here. Okay, that's connected to the other node in the hierarchy. So each node is connected to one other node. Okay, and then you have a hierarchy and a parent-child relationship when there's only one mutual connection between two connected nodes. So if I look at these two, you have basically the parent and then the child, the parent and the child, parent, child, and so on and so forth. If this was connected, it would be, so you essentially have kind of this parent-child relationship, and you don't have this relationship or this direct path from, one of these trees or one of these leaves down here, branches or leaves down here, back here, without going through all of the other parents. Okay. So, one of the things that's why this is used is it's scalable. You can easily add many devices to the network because you're adding it only to, as a node and in addition to the node either above it or below it. And so the traffic only has to, go between those nodes. And so you can just grow this without too much impact on performance. It's very scalable, as well as manageable in terms of running cables or wiring or anything else that you have to. But what the problem is here is that root node, right? It's really the single point of failure. If that fails, then how are you going to communicate anywhere else, right? That's really where all of the management is happening. And so if it were to fail, what would happen? So, it's similar to the star topology in that regards. It does have a single point of failure, and most of these did have something like that. Okay. And then here, it's not necessarily the amount of cabling, but the number of cables that you need. So, you're going to have to connect every node is going to be connected to different nodes. So they might be short, but you're going to have a lot of cabling to worry about. All right. So in that sense, it might be a little bit hard to maintain, but the main thing here is if the root node were to fail, then the entire network would go down. Then you have the hybrid topology. So the hybrid topology in and of itself is not a topology, but you can think about it as a combination of multiple topologies, right? So when your overall topology is comprised of two or more different topologies, it's referred to as a hybrid topology. And hybrid topologies are most commonly encountered in larger enterprises where you're going to have individual departments that have topologies that are different for a variety of reasons. It could be just because of the way historically the departments were built. It could be because there are security or performance requirements. It could be for a lot of reasons, right? So once you connect those two disparate topologies, then you get a hybrid topologies. So what results is you end up with your advantages and disadvantages are dependent on what the original topologies were, right? So lots of reasons why hybrid topologies are used, but they have one thing in common, and that's they're flexible, right? There are very few constraints on the structure for a hybrid topology, and you can incorporate multiple topologies into one hybrid setup. So as a consequence or as a result of that, hybrid topologies are very scalable. The scalability of hybrid setups makes them well suited to much larger networks. And you can bring in, like I said, you can bring in legacy networks into a hybrid topology. You don't have to go and rearrange or redo all of your networking in one network just to make it conform with the topology of another network. You just combine them using some kind of a network node, a router, or switch to take care of that. But that's where some of the flexibility comes into play. But unfortunately, hybrid topologies can be quite complex, depending on the topologies that you decide to use. Each of the topology that's part of your hybrid topology will have to be managed according to its unique requirements. So before, I had either a ring topology or a tree topology to manage. Now I've got to worry about managing both of them, right? So there isn't uniformity. It's not homogeneous, which means you need different skill sets, different tools, different hardware, different equipment, different software to maintain networks. And so when you're troubleshooting, when you've got problems, depending on, even if you know which segment your problem is in, you've got to use different tools and techniques and approaches to be able to debug them. Okay, so essentially, the administrators, jobs of administrators just become that much more difficult. And like I said, sometimes it's even necessary to get different skill sets. All right, so we've talked about the topologies. I want to go back to the question of what your home office or your home would look like, right? So let's just go back and review some of these physical let's start with the physical topology, right? So one, is there, would it look like a bus topology and a single cable running through the entire house with each of the devices then having one connection? Is that what it is? Would it be a star topology? So in other words, would all the devices have one connection back to a centralized network node, which would manage the network? Would that be what it's like? Oops, wrong way. Or is it a ring? Do you have a ring in your house, either unidirectional or bidirectional ring? Is it a mesh? Is every device connected to every other device? I mean, you certainly can talk to every other device in your house, right? You don't have to just talk to one device, or could it be that you've got a mesh set up? Or is there some kind of a tree where every device is only connected to one other device and you've got this root node?